Hey guys, welcome back. Today, Casey's going to talk through pipe design and naming and editing pipes and structures. A lot of times it can be easy just to get the pipes into the software and get them working, but it might be a whole other thing with naming them properly and editing them as need be. So sit back and watch and let's learn as Casey shows us how to do this.
Welcome back, guys. This is Casey. We're going to be continuing on our Civil 3D pipe network series. So in this video, we're going to be going over how to edit and design our pipes and structures. So in the last video, we went ahead and created our alignment, we created our pipe network, and we went through the placement of our pipes and our structures. So this video, we're going to be talking about how to design our pipes and structures using Civil 3D, as well as how to set up the correct naming format and set up our pipe network and pipes and structures so that it's easier for us to use them to do design work in Civil 3D. So the first thing that we're going to go over is we're going to go over our flow direction. So we want to make sure that our pipes are set up such that the upstream most point, or intended upstream most point, it is the upstream most point, and the downstream point is the most downstream most point. So we can select one of our pipes or structures, and we can go ahead and hit this modify drop down tab. So whenever you select a pipe or a structure, it's going to take you to this pipe networks tab as opposed to any of these other tabs here. And under this modify tab, we're going to have a couple of extra options, one of which being change flow direction. So if I click this guy, my command window is then going to prompt me to select the intended upstream starting point in plan view. So I can go ahead and select that guy. And then I'm going to go ahead and select the intended downstream ending point in plan view, which is all the way down here at the outflow of our pond. As you can see, it's going to select all of the pipes and structures between the two. I can go ahead and hit enter, right? And now the flow direction should be correct. And I can do the same for these couple guys that weren't included in that run. So I can select one of the pipes or structures, hit modify, change flow direction, select the intended upstream and the intended downstream, hit enter. Same thing for this guy. Select the intended upstream and the intended downstream, hit enter. And now the flow direction for all of our pipes should be correct. So now that we have all of our pipes and structures in, we have to name them. And so the naming convention is extremely important because you might end up exporting your pipe network into another software to do hydraulic grade lines, and when doing that, the naming convention is going to automatically populate in the other software. And so there's a certain way that we name pipes and structures so that it's easier to design them both in Civil 3D and in other softwares. So the way that we typically do this is we name our pipes after the most upstream structure on the pipe. So this pipe here is connected to two structures. It's connected to the outfall here in the pond, and then it's connected to the single wing catch basin upstream. So the pipe should have the same name, or a name that coincides with its most upstream structure. So in order to name our structures, right, typically we start from zero and name from downstream to upstream. So this guy, the outfall into our pond, and our Storm A network, so this is the pipe network Storm A, the name of this most downstream structure is going to be A naught. As such, go ahead and do caps, A naught, or A0. Okay? Right? And then the name of the next structure up will be A1, and so on. And so because the pipe has to have a name that coincides with the most upstream structure that it's connected to, the name of this pipe will be pipe A1, and so on. So a quick way to rename your pipes without having to go and select each one of them one by one is you can select one of your structures or pipes, starting from where you want to rename them, and you're going to want to select them structure pipe, structure pipe, structure pipe, from downstream to upstream. So I'm starting downstream, structure pipe, and I'm going to continue this all the way up to the most upstream point along this alignment, structure pipe, structure pipe. We'll just go all the way up, structure pipe, structure. And then we're going to go ahead and hit this modify drop down again, which is going to give you a couple more options, and we can hit rename parts. So this is going to open up this little tool tab for you, where you're going to be able to select set a naming template for your structures and your pipes. So as you can see, this is kind of the default naming template that they give to you to work with. And so the key thing that you need to know is this counter here, what it does is you input a starting number. So if I click on this little tab, it's going to open up some extra options. this counter here, so where it says next counter, you're gonna input a starting number, and then you're gonna input an increment value. So say I inputted the starting number as 0 and the increment value is 5. The first structure, because this is the counter under the structure naming template that I clicked this guy right here. The first structure is gonna be 0 at the starting number, and then if the increment value is 5, the next structure that you selected will be 5. So the counter is everything inside of the carets. So these carets here, and everything inside is the counter. So under this name, you don't want to change anything inside of the carets. So I can delete the parentheses, those aren't a part of the counter, but everything else outside is a part of the counter. So because our structures, we're just going to name them A, not, A1, A2, and so forth. We'll just put an A in front of this counter, and then everything inside of this carets isn't going to pop up actually as this carets. It's just going to be whatever number is next in the counter. So the starting number is going to be 0, and the increment value is going to be 1. We'll go ahead and press OK. And then for our pipes, we do pretty much the same thing, except our starting number is going to be 1 because that first pipe has to correspond to its most upstream structure. So that first pipe has a downstream structure, A0, and an upstream structure, A1. We want the name to correspond to the upstream structure, so the starting number for our pipes is going to be 1 instead of 0, and the increment value 1. And then we want to name our pipes, again, without the parentheses, and then we're just going to name it pipe A, and then whatever the counter is. So it'll be pipe A0, A1, and so forth. We'll go ahead and press OK. And then I usually always select this option of renaming existing parts. So the conflict of names would be if the counter and the name automatically, or excuse me, the automatically generated name from our naming template reaches a structure that already has that exact same name. If you hit skip number, it'll just skip that number and then rename it with a new number. So we don't really want that. It can mess up your naming template. So I typically always select this rename existing parts, and it's just going to rename all of the structures and pipes that you selected in order, and it's going to rename them all with this naming template completely from scratch. So we're going to go ahead and press OK. And then now if we click on our most upstream structure, you'll see that it's named A7, and the pipe A7, and so forth all the way down. Now you can come and you can rename structures and pipes one by one if you need to change one structure or pipe specifically. If you just click on them and then the name here in the properties panel. So this structure right here is A4. So whenever you have a structure or pipe that's breaking off of another structure, right? So we kind of have this main run of pipe that we've already named all the structures and pipes on, and then we have these two little catch basins that kind of break off, right? So the way that we name these guys is we just add a period and then 1, 2, 3, 4, 5, and so on. So this guy is A3. So then this structure will be A3.1. And if there was another structure, say here, that was connected to it, that structure would be A3.2. Now, because this pipe has to be named in correspondence with its most upstream structure that it's connected to, which is A3.1, this pipe will then be pipe A3.1. We're going to do the same thing for this other guy over here to our left. Give it a second to load. This guy will be, this is A4, so this structure will be A4.1. A4.1. And then this pipe will be pipe A4.1. Okay, so now we have all of our structures and pipes within our Storm A pipe network correctly named. So that's going to make designing our pipes and structures later on a lot easier. So now in our plan view, we're going to want to set up the last thing that we need to generate a good grading plan or a good pipe network plan, which is our labels. So when we created our pipe network, we went ahead and specified the label style, so they automatically populated. So you can see that there's these labels here, and they're really small. Why are they really small? They're really small because you have your annotative scale set to 1:1. So all of these labels here are annotative. So if we go to, say, the site plan of this site, you'll see that our scale for our site plan as well as our grading plan, if we go to our grading plan, is set to 1:60. So we're going to go ahead and go back to our model space, and we're going to change our annotation scale to 1:60 because all of these labels are annotative, and you'll see them all populate to a much more appropriate size. So So we can grab them, and then we can grab these little grips to move them around. So you're going to be doing a lot of moving the labels around to make sure that they're not cluttered and you can actually read them. So we're just going to do that really quick. We're going to move around all of these labels. We typically want all of our structure labels to be liters like this. So you're going to have to move each and every one of them. And then the pipes, if it's a super short pipe, like this guy is a really short pipe, the label is actually longer than the pipe itself, so it's much more appropriate for this to be a liter. Whereas this really long pipe, the label can just remain along the length of the pipe. And if you click it, there's this little diamond shape here where you can slide the label up and down the pipe if you need to move it anymore. So again, we're just going to go ahead and move all of these labels off to the side so that they're in more appropriate locations and much more legible. And then on these really short pipes, we'll move the pipe labels away as well. Same with this guy. I'm going to go ahead and freeze this parcel, these parcel layers, just so we can declutter our screen a little bit. Same with this pipe. We're going to go ahead and make him a liter. Okay. And then all of our structure labels, again, the SSA command will work on them. So I can grab one, I can do select similar, and it's going to grab all the other structure labels. And then I can grab one of the pipe labels and run SSA, and it'll grab all the other pipe labels. And we can just go ahead and throw these on our CG&1 storm layer, which is where we put all of our pipe and storm layers, labels. And as you can see, the label style that we've specifies some really key pieces of design information about each one of the pipes. The ones being the rim and then the two inverts. So what does this mean? The rim at a structure is essentially the elevation in which water enters the structure. So this term, rim, is really important because there's a variety of different terms that refer to different structures. So this catch basin, rim, would not be the most appropriate term. Rim is a more appropriate term for manholes. That rim at the very top of the manhole. Manholes are obviously covered by a manhole cover, so water doesn't enter into manholes, but rim is the appropriate term for manhole. So this elevation here is going to be the elevation at which the manhole rim sits at, right? So if rim's not an appropriate term for these catch basins, what is an appropriate term? Well, we can grab this label style and we can go to the style itself, which is CVLX PR Storm, and we can change it to PR Storm Catch Basin, in which you'll see that the term will change to top. So what does this do? It tells whoever's building out the site, the contractor, that we want the top of the catch basin to be located at this elevation. Inverts. What are the inverts? Well, the inverts are the elevations of the pipe at this structure. So the invert in, which is going to be this pipe, it's going to be the elevation at which this pipe enters into this structure, and the invert out is going to be the elevation at which this pipe exits the structure. So it's essentially the elevation that water is coming in and the elevation that water is going out. Well, if you have a pipe, pipes have tops and bottoms, so the invert is going to be the bottom elevation where water can first start to come in. If water is all the way up at the top of the pipe, then it's all the way at the bottom of the pipe too. So we have terms for the bottom of the pipe, invert, just like we have terms for the top of the pipe, which is crown. So the inverts are the key information because that's when water will start to come in to come into the pipe. So these are all elevations. The top, the invert in, and the invert out are all elevations. This STA guy here is the station. So the station refers to at what point along the alignment of which that structure references is that structure located. This is why it's important to change the reference alignment for structures that are not located along this primary alignment. So this alignment here is our storm A, and then this alignment here, which is going to our structure A 3.1, we're going to go ahead and rename this alignment A 3.1. So this structure needs to have alignment A 3.1 as its reference alignment. So I can grab the structure and I can click Structure Properties, and then I can go to Reference Alignment, and as you'll see, it's Storm A and not Storm A 3.1. So we're just going to go ahead and change that, hit Apply, and as you can see, the value for the station is going to change. So it's really important that your structures reference the correct alignment. So I'm going to do the same thing for this guy. This alignment, which was formerly named Storm A2, now it's along, the alignment runs along pipe A 4.1 and ends at structure A 4.1. So we'll just go ahead and name it A 4.1. And then we're going to go ahead and select the structure. You can see here the station is 5 plus this number here, 7.39. Well, that's the station that the structure is along this alignment, because this alignment is currently the reference alignment for this structure. So that's not accurate and doesn't give an accurate depiction of where the structure is located on its own personal profile as well as in plan view. So we're going to select the structure, come to structure properties, and change the reference alignment to the appropriate reference alignment, which is Storm A 4.1. And as you'll see here, the station value will change here. And now all of our structure labels are correct. So one of the things that you'll notice that these values for our inverts are like negative elevations or really, really low elevations, whereas the elevation of the actual site is, in the 800s. So, say right here at this structure, we're at elevation 860, and the inverts, you can see one of them is at 860 and the other one's at negative. So this would infer that this structure is 860 feet deep, which is obviously not accurate. So one of the reasons why we don't go ahead and set slopes and elevations for inverts when doing the conceptual storm plan is because it's much, 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 much easier to do when you already have your pipes and structures created in Civil 3D. So what you can do is you can start at, say, your most upstream point. So at our most upstream point, we have a rim elevation of 888 for this catch basin, which again, rim is not the correct term. So I'm going to go ahead and select all of these structure labels because basically all of our structures, besides this guy, are catch basins. And we could just go ahead and change the style to CVLX PR Storm Catch Basin. Okay, so now we have our term for our elevation of the structure as top. So we're at a top elevation of 800, which means it's probably more appropriate for our pipe or the invert of the pipe exiting the structure to be, let's say, maybe 3 to 4 feet down. The amount of cover that you provide for each pipe can vary, but we typically want at least 1.5 feet of cover. So let's say we have 3 feet of cover. So we're at just about 889, so we might be at 885 to be a little over 3 feet of cover. So for this pipe, we have a start and end invert elevation, right? So our end invert is going to be the downstream point. So we're going to go ahead and select this guy, and the start invert should be 885, right? And then you'll see that it changed this label here. So I actually had that backwards. The end invert is going to be the most upstream point, and the start invert is going to be the most downstream point. So we'll change the end to 885. And then what we can do, since we have the end invert at 885 where we want it, we can select the pipe, select pipe properties, and we'll go ahead and drag our pipe properties over here. And then we can change the pipe slope holding one of the ends. So you can hold the start or the upstream portion of the pipe, or you can hold the downstream portion of the pipe. So I'm going to do hold end because the end portion of the pipe is what's now correctly set to the right elevation at 885. And I'm going to set the pipe slope to -1%. Why do I do -1% versus 1%? I do -1% because we're working from upstream to downstream, which is why I set it at negative. So if you're going in a certain direction and you're going down, then that means your slope is going to be negative. So I'll hit apply. And then as you can see here, the start end invert is going to be 884.7, which is lower than 885, which is correct. I can go ahead and press OK. And then now this pipe label here is going to automatically update. This pipe label contains information about the pipe. It contains the size of the pipe in diameter, the type of the pipe, the linear footage of the pipe, and the slope of the pipe. So that's going to automatically update whenever we change our pipe properties. And then here, the invert in at the other side of that pipe is going to automatically update as well. And then what we typically do for storm systems is we have the inverts at each structure, the invert in and the invert out, match elevations, or we'll have the invert out be 1/10 of a foot lower than the invert in. But for this sake, we're going to have the match elevations. And so the way that we can quickly do that, you could grab this pipe and you could make the end invert elevation of this pipe the same as the invert in of this pipe, or you can simply grab your structure, hit structure properties, hit connections, and then you can select both pipes which connect to the structure. And as you can see here, when I select them, they're going to get highlighted in blue. I can right click and I can hit match inverts, and then I can match the inverts of both of these pipes to one of the two, and I'm going to match it to the one that we already set, which is pipe A7. Press OK, hit apply, OK. And then as you can see, the label, the invert out label here, is going to automatically update, and then the slope is going to automatically update. So it's an extremely high slope because the end here is at some weird funky negative elevation. But once we update that, this slope will be updated right? And so we're going to want to, again, run this pipe at 1%. So we'll select the pipe properties, and then we'll just hold the end and then type in -1%. Hit apply and then press OK. That's going to update our pipe label. And the reason that our pipe label is showing at 1% instead of -1% is just because the pipe labels are set default to show the absolute value. It's just, we don't typically refer to pipe slopes in -%, but when working from upstream to downstream, you're going to have to work in negative slopes. Now that I've shown you how you can change the inverts and the slopes of the pipes extremely efficiently and easily and have these labels automatically update for you using Civil 3D, we'll talk about the general rules for pipe slopes as well as structure invert elevations. So for pipe slopes for storm, it depends on the type of pipe what slope is going to be the minimum slope, but typically we want no less than 1% slope. Anything less, your water is going to flow extremely slow, structures and pipes are going to get backed up much more easily, and many jurisdictions require you to have that 1% slope on all of their stormwater systems. Now, typically we don't want to go north of 10% slope because you're going to have to start putting collars on your pipes to essentially keep them from getting damaged from being at an extremely high slope, or from your water moving extremely fast through the pipes. So we don't want to go north of 10%. However, in some circumstances, it can be appropriate to go north of 10%. And there are some circumstances where it can be appropriate to go less than 1%. Certain areas of the country and certain areas of the world, there's so little elevation change that pipes have to run at a very shallow slopes. We've done plenty of projects in Florida in which the minimum slope is 0.5% versus 1%, just because it's unrealistic to require all the pipes to be at 1%. But as a general rule, you want to keep your pipe slopes at minimum 1% and probably keep them below 10%. Okay, and then for our structures, we want to keep our structures as shallow as possible. We don't want our structures to be extremely tall, very deep structures with ladders inside of them. People have to crawl all the way down to the bottom of the manhole, etc. The taller a structure is, the more expensive it is, and these structures can be on the magnitude of $10,000 or more, 5-figure structures. So the shorter they are, the less expensive they are, which is better for our clients. So that's what we want to aim for. And you can continue this process all the way throughout the entire pipe network. But one thing that's key to know is that as civil logistics and as engineers, we always design from our constraints. So typically, instead of designing from the most upstream point all the way down, you'll probably do that exact same process from the downstream point to upstream. As a general rule, we're always working upstream to downstream. I just wanted to demonstrate that sort of negative slope dynamic that goes on when changing slopes from upstream to downstream, which you may do under certain circumstances. However, there could be scenarios in which your constraining point, or the constraint in which you design your pipe network from, could be a spot of very low cover. So somewhere in the middle of your pipe network, you might have, or might be very restricted on cover and have to have one of the inverts or one of the pipes set at a certain invert and slope, and then you design from that middle point. So you'd have to design downstream from that middle point and upstream from that middle point. So it's good to know, get familiar with slopes in negative and positive values and how you can use them to design going downstream or going upstream. But as a rule, we always design from our constraints. And once you've punched in all of your invert and slope values for all of your pipes and structures here, you'll be ready to generate your profiles. And then your profiles are going to give you a great look at how much cover you have throughout your pipe network. And that's going to give you the tools to change inverts, to change slopes in order to meet the cover requirements while keeping your stormwater system as shallow as possible and as cheap as possible.